So we'll do the Indian monsoon in two podcasts because it's kind of a long story that I have gathered here. Obviously, we already mentioned Mohenjo-daro, Harappa, and we also mentioned that the Indian subcontinent also has the summer monsoon and the winter monsoon. So the southwesterly monsoon, which we also invoked in the East Asian monsoon, carries water vapor all the way across into the East Asian region during the summer, boreal summer months. And this monsoon, this southwesterly jet swings around more southerly or more southward during some decades and more northward during other decades, and of course it's affected by ice ages, deglacial, glacial stages as well. And this is the region we will worry about for the Harappa culture, and then we expand into the subcontinent. The northeast monsoon during October, November, December affects only a small part of the country, but still is a big part of the history. So we'll see what are the data we have and what the cultures went through during the Holocene. This is an example of how reconstructions of the summer and winter monsoons. So this is the studies on the northeast monsoon, and these are the studies on the southwest monsoon during the Holocene. Here is the little ice age, and this is the Holocene climatic optimum, and then we have the medieval warm period and the little ice age here. Okay, so the Younger Dryas there, which I mentioned. And the main thing I want to point out with this paper is that they have a nice meta-analysis of the previous studies that have reconstructed the monsoon. For example, this study here looks at the summer monsoons being weak, strong, weak, and ameliorated conditions and strong. But you can see that another study which covers part of this period as well has a slightly different interpretation, here being intense monsoon as opposed to this interpreting it as weak monsoon, and there are other periods of agreements and disagreements as well. We have to keep this in mind when we interpret the archaeological and other evidences, because as we saw in the case of the East Asian summer monsoon and winter monsoon, Indian winter and summer monsoon also may have had a non-stationary relation with each other through the Holocene, which we haven't looked at and probably we will not look at, and that the interpretations of past proxies for precipitation, pollen, soil moisture, vegetation, etc. may be confounded in determining when was the precipitation peak and what the ecosystem feedback did in terms of soil moisture peaks and vegetation peaks and so on. Maybe some of those sorts of differences can explain these differences in reconstructions. Keeping that in mind, we look at the present day international borders. Here is Pakistan, here is India with its northwestern desert over Rajasthan, and then Gujarat, Saurashtra. Here the western Ghats end about here, and then rainfall drops off. And we have all these rivers, of course, Indus being shared, always a point of negotiations in renegotiations. All these tributaries then combine and become Indus before running off into the northeastern Arabian Sea. Jhelum, Chenab, Rabi, Beas, Sutlej, and Yamuna is here going off, meeting the Ganga, and here is the Hakra and Gagar, and so on and so forth. With that orientation, we will look at a couple of reconstructions of Harappan sites. This is the early and mature Harappan site, 5200 to 4500 to 3900 years before present. So that's calendar years pegged to some year when the paper was published around 1950. And this is for late Harappan sites and painted grey ware sites, so going from 3900 to 2600 BP. And you can see that the settlements were much more widespread during the early and mature Harappan civilization times, and we'll come back and look at much more details in the next podcast on how these things changed and how the rainfall intensity was changing along the way. Saraswati River is invoked in many of these historical documentations, and evidence for Saraswati is looked for. Some claim it was there, but you can see the question mark here, so it isn't entirely clear. Nonetheless, you can see late Harappan and painted grey ware sites show a complete redistribution of population centers, maybe more here, much more here in the later periods, and much reduced all along here. So the major story goes that Saraswati disappeared, which was a major cause of the decline of Harappan culture. Obviously, you cannot call it collapse because it went through multiple stages: urbanization, deurbanization, and reurbanization, as we will see a little bit later on. This paper uses AI to argue that they can do better reconstruction of the mature early late phase, later late phase, and post-Harappan phase in terms of the settlements here. Major cities, towns, and villages are shown in the context of the paleo data that are used to do these AI calculations with archaeological evidences. And again, you can see in the mature phase there is a large distribution with a number of cities. It's considered one of the first cultures to civilizations to develop cities, concentrated settlements related to intense agricultural productions during good monsoon years, regimes, and maybe requiring social stratifications, food production versus trading, counting, serving the empire, and so on and so forth. Early late phase, you can see some redistribution already to these two centers with much reduced population here. Later late phase, 3600 to 3300 BP, again maybe some reurbanization here, so you can see the cities are still there, but maybe deurbanization happens, and then in the late or the post-Harappan phase during 3300 to 2700 BP, the distribution, the total numbers have reduced, and they're redistributed as well. Let's look at then the spatial extent of the Indus Valley Civilization IVC during 5300 to 3300 years before present, marked by dotted green lines along with the Indus River. Brown line shading indicates the spatial pattern of June, July, August, September rainfall in the modern day from the gridded precipitation data set called GPCP, Global Precipitation Climatology Center monitoring product. So here cave is shown with a black star. So we are looking at the Harappa civilization, Indus Valley civilization, Indus River, and the distribution of rainfall in the present day with the Western Ghats concentration, Himalayan rainfalls, the Burmese mountains, and so on. Of course, this is the core monsoon zone, and here is the Guja kingdom in the Tibetan region. Sahia cave is up here. So how the archaeological evidences and the cave evidences can be interpreted for rainfall and soil moisture, vegetation, agricultural productivity, of course, has to be kept in mind in those different reconstructions of monsoons we saw, which differ in terms of when the monsoon was weak and when it was strong. So the second panel is showing the same as A, so same region except spatial extent of the early, so 3400 to 3050 years BP, and later Vedic periods 3050 to 2450. The hexagons depict other cave sites mentioned in the text. So there are several other cave sites looked at here. You can see Hoti, Kunf, Mula, and so on and so forth. And you can see the expansion of the domain here. This is the Indus Valley civilization again, with Harappa noted here, and the Indus Valley, Indus River, and the early Vedic civilization over there. Looking at data, we are looking at the 6,000 year period, and I like these graphs where the cultures are mentioned, which kind of implicitly assume environmental determinism, climate being a driver for these transitions and changes, cultural reorganizations, but keeping in mind that we don't always agree with them. We are looking at the cave delta O18, which is a proxy for wet and dry periods as well. So you can also look at them in terms of years BC and AD, or before Common Era and after Common Era, if it actually it's much more convenient than this one. Nonetheless, looking at various transitions with these blue arrows, and looking at various periods like the Holocene climatic optimum, the Minoan warm period, Roman warm period, Dark Ages cold period, medieval climate anomaly when the Vikings colonized Greenland and started agriculture and then went extinct as climate got cold again. So Guja Kingdom got established and went extinct here. End of the Guja Kingdom also happened during the Little Ice Age, when cooling was mostly around the European regions, but obviously there are signatures in the Sahia caves as well. Reading off some of the cultures, Maragar culture, early Harappan regionalization here. We'll look at these in a table with relations to characteristics of various economic and agricultural activities in each period and the intensity of the monsoon. But you can already imagine here. Okay, so cold periods and warm periods, climatic optimum of course is the warm wet period, and you had the drying here, which is also present in European cultures in terms of impacts. Mature Harappan phase, where integration and urbanization happened with improving monsoon intensity, and then late Harappan deurbanization was related to a lot of activities that were related to reduced agricultural productivity, but urbanization and societal hierarchies, complex societal structures were already set up. So it isn't clear how the cultural responses relate to social reorganization versus climate impact. Of course, they cannot be separated, but the resilience of the societies would have been altered by the reorganization here. So the Minoan warm period, early Vedic period happened here, the late Vedic period when the cooling was happening, and the Majanapadas period. I'm not even saying it right, I'm sure. I'll have to ask my friend Professor Radha Kumar from St. Xavier's University in Mumbai, since she works a lot on these things and probably knows much more about the sociological, cultural history aspects as opposed to these environmental relations that we keep probably over-interpreting. Here is the Maurya Empire, the Indo-Greek kingdom, and then you have a lull, then you have the Gujo kingdom and the end of the Gujo kingdom. Looking again at the Gujo kingdom here, are the Sahia cave evidences consistent with northern hemisphere temperature anomalies? Yes, they are highly consistent. Even the resolution of the two can be very different depending on where the data source comes from. If you're getting ocean sediment cores or ice core delta O18s, then you'll have different resolutions compared to cave stalactites, stalagmites, and stalactites. But leaving that as it is, we are again looking at Roman warm period, Dark Ages cold period, medieval climate anomaly in the Little Ice Age. So you can see the Guja kingdom got established and then went extinct here in the middle of the Little Ice Age, as we said. This is a little bit more detail about the climate and cultural relationship over the past 6,000 years in the Indian subcontinent. We are looking again at total organic carbon in percentages, indicating strength of the monsoon increasing this way in the cave delta C13s and other evidences used here, again with bands signifying various cultures with a bit more detail here. So over the past 6,000 years in the subcontinent, how have the climate and cultural relationships changed? The small triangles at the top here mark the historical records of droughts and famines. These droughts and famines are at annual and decadal scales because that's the time resolution at which you can resolve these things in proxies. So even though we are saying summer monsoon and winter monsoon, the proxies don't allow us to distinguish which monsoon was deficit, but you can assume that for this region in the northwest it has to be the summer monsoon. Okay. The thicknesses of the triangles do not represent ages, so it's just something to keep in mind. Again, keeping in mind the BCE CE here, we went from AD and BC to BC and CE. Again, in different papers they use different depending on the timing of when we switched from AD and BC to Common Era and before Common Era. Nonetheless, you can see starting 6,000 years ago, monsoons intensified through the climatic optimum, and then there was drying and then some ups and downs. So without going into details of the climate proxies themselves, let's read off again the early Harappan phase, where we had early regionalization and agro-pastoral settlements. So monsoons were favoring the livelihoods based on agriculture. There's some horrendous noise being made outside by the cleaning people. I hope it doesn't disturb my recording. Mature Harappan phase was associated with developments of urban centers, so wealth and population centers and social stratification in terms of maybe division of labor into food production, trading, accountants, people who served the empire, and so on. Late Harappan phase here during 2000 BCE onwards, here was associated with de-urbanization, so the reorganization that we saw. Early Vedic period had late Bronze Age Indo-Aryan migration in the Indus Valley. Middle Vedic period had Iron Age settlements in the Ganga plain, so again explains the ramp up of the intensification of the monsoons. Second urbanization happened during the Majanapada's kingdom, and the Maurya Empire was associated with irrigation systems, land and water tax, and we will see that things that happen during intense monsoons indicate efforts or innovations to increase agricultural yields. We'll also look at invasions that were related to droughts elsewhere in the northwest part of India, in the Central Asian regions, that led those militarized cultures to invade India for food and other resources. Okay, so small political regions began to emerge after the Nanda and Maurya dynasties here, leading to extensive trade expansion. So do the trades happen when there is less monsoon and need to find salt and other things elsewhere because you don't have everything you need, or do they happen when you have a lot of wealth and you are feeling adventurous with your militaries? But nonetheless, there we are. And the classical period Gupta dynasty, so 200 to 800 CE, was associated with the decline of the Roman trade as well. And the early medieval period here was associated with invasion and conquest by Ghuri, invasion by Ghazni into India, and then came the Delhi Sultanate with population and economic growth. Mughal Empire lasted for a while with increased agrarian economies, infrastructure like roads for trade and so on, and Mughal Empire lost and gave rise to, or allowed, the British colonization to establish itself, and they were associated with declined agricultural productivity. And we know that a lot of the droughts during this time, like the Calcutta famine, led to millions of people dying, not so much directly from the drought itself, but the British were forcing farmers to grow cash crops and grains they needed instead of what was suitable for the climate of the time. So drought was delivered by nature, but humans created famines out of those. And Mike Davis and Jared Diamond and so on write on it. Books like El Nino and Lake Victorian Holocausts address how climate perturbations were converted into famines and mass mortalities by human activities like the colonizers. Okay, so let's leave this here because this nice long table has lots of details that I want to go into with a little bit of time. So we'll come back to that in the next podcast. Okay.